Determine if the following series is convergent or divergent. We have the sum from n equals 1 to infinity of the sum of 2 and 3 to the power of n divided by 5 to the power of n. We can actually write this as the sum of two infinite geometric series, and then determine if it converges based upon the value of r. Recall when we have an infinite geometric series, the formula for a sub n fits the form of a times r to the power of n, where r is the common ratio, and if the absolute value of r is less than 1, the series converges, and it converges to a, the first term, divided by the quantity 1 minus r, and if the absolute value of r is greater than or equal to 1, the series diverges. Let's begin by writing the given series as a sum of two series. The given series is equal to the sum from n equals 1 to infinity of 2 divided by 5 to the power of n, and then plus the sum from n equals 1 to infinity of 3 to the power of n divided by 5 to the power of n. And now if it's helpful, if we wanted to, we could include a factor of 1 to the power of n in the first sum. Notice 1 to the power of n is always going to be 1. In this form, it's probably easier to recognize. We can write this as the sum from n equals 1 to infinity of 2 times 1/5 to the power of n. And then for the second infinite series, we'll write this as plus the sum from n equals 1 to infinity of 3/5 to the power of n. So the next step, let's identify the values of r for both geometric series. Notice for the first series, r is equal to 1/5, which is less than 1, and therefore the series converges. And then for the second infinite series, we have r equals 3/5, which is less than 1, and therefore the second infinite series also converges. Since both series converge, the original series also converges. So we'll go ahead and state that the series converges. But let's also determine what it converges to by determining the infinite sums of both of these infinite geometric series. To do this, we'll have to find the first terms. For this first infinite geometric series, notice when n equals 1, we have 2 times 1/5 of the first, which indicates the first term a sub 1 equals 2/5. And again, we have the common ratio r equals 1/5. And then for the second infinite geometric series, when n is 1, we have 3/5 to the power of 1, which is 3/5. So a sub 1 is 3/5. And we have r equals 3/5. So now we'll find both infinite sums, and the sum of those two infinite sums would be the sum of the original infinite series. So first we have the infinite sum is a sub 1 or 2/5 divided by 1 minus r, which is 1 minus 1/5, which is 2/5 minus 4/5. And 2/5 divided by 4/5 is equivalent to 2/5 times the reciprocal of 5/4. Simplifying before multiplying, 5 divided by 5 simplifies to 1. 2 and 4 share a common factor of 2. There's 1, 2, and 2, and 2 2s and 4. And the infinite sum for this first infinite series is 1/2. And now we'll do the same for the second infinite series, where a sub 1 is 3/5, and r is also 3/5. So the infinite sum is equal to 3/5 divided by 1 minus 3/5, which is 3/5 divided by 2/5, which is equal to 3/5 times the reciprocal of 2/5, which is 5/2. Again, simplifying before multiplying, 5 divided by 5 simplifies to 1, and the infinite sum is 3/2, which indicates the original infinite series converges to 1/2 plus 3/2. So again, for the original infinite series, the infinite sum is equal to 1/2 plus 3/2, which is equal to 2, which indicates the series converges to 2. I hope you found this helpful.